Welcome to lecture number 93, and as I told you, I will spend some time on armature winding, of which lap winding we have discussed earlier. Let me quickly go through that and the convention that I will follow, so that windings can be done with ease. For example, in case of say lap winding, suppose there are number of slots are suppose 16, total number of slots 16. What are the things I will be using? Double layer winding, DC machine always double layer, and suppose number of poles of the machine is 4, and suppose and number of commutator segments is equal to C, which is equal to S, that is equal to also 16. Achha. Now, this diagram is what? This diagram is there I have drawn two vertical lines side by side. They are nothing but coil sides in a particular slot. This is suppose some slot number 1, this is slot number 2, which will also carry two coil sides. Coils, of course, they will be coil, but to begin with, let us imagine in this way. In each slot, there will be two coil sides. On the upper deck, there will be a coil side. On the lower deck, there will be a coil side. So, that way, if you call this is slot number 1, this is 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 slots are there. And in each slot there will be two coil sides. Okay. Now, while making a winding, two things are important in case of DC machine windings particularly. What are the two things? Each coil will have two coil sides and they will be separated in space in terms of slot numbers. The coil span is a term, coil span should be how much? It should be number of slots per pole always. So, that full pitched coil 16 by 4 is equal to 4. We are just revisiting some of the things we have discussed earlier, so that we can also discuss about wave winding fruitfully. Therefore, this is the coil span, and each coil at the end will have two terminals, and these two terminals are to be terminated on these copper strips. These vertical lines are mica insulations. So, in case of this is the thing, these are the slots armature. Okay. These are the teeth, this portion is teeth, okay. And in these slots the conductors, multi-turn coils are placed, and this is the commutator segment which is connected on the shaft. Both armature and commutator segment will rotate, and brushes will be in space, they will touch different commutator segment, that we have discussed earlier. So, this is the arrangement, mind you, and so commutator segments will be nothing but a replica of the slots only at a lesser diameter, at a distance from this. Now, the thing is the induced voltage depends on the coil sides, flux will be present only in this portion. Okay. Achha. Now, let us see how to start the lap winding. So, coil span is 4. Suppose I say that this is commutator segment 1 and this is commutator segment 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 13, 14, 15, 16. This is the and then this is 16. What is this number? Once again 16. Understood? Because it is I have developed the diagram. Acha, now these coil sides I will number in a interesting way. The upper coil side, this is suppose slot number 1 and I will number the coil sides as 1 and 1 dashed. Top one is 1, below 1 is 1 dashed. This is 2, 2 dashed. This is mind you one slot, slot number 2, this is slot number 1, like that 3, 3 dashed, 4, 4 dashed, 5, 5 dashed, 6, 6 dashed, 7, 7 dashed, 8, 8 dashed. This is slot number 8, this is 9, 9 dashed, this is 10, 10 dashed. This is 11, 11 dashed, 12, 12 dashed, 13, 13 dashed, 14, 14 dashed, 15, 15 dashed and this is 16, 16 dashed. After that these slots will be once again 1, 1 dashed like that. Okay. So, now where is the first coil? First coil, if suppose it is this one, what will be its end? Its ends will be on 5. So, coil span is the word, coil span. All coils, fortunately they are identical. If you understand one coil, other coils are same. So, first coil is this coil side is 1 on the upper deck of this slot number 1, its return is on slot number 5 and that is 5 dashed. So, if you now complete this coil, is 5 dashed. So, it will be like this and it will go like this 5 and it will come here. Now, the question is these are the two terminals of this coil. Where should I terminate? Here on the commutator segments. In case of lap winding, if you the coil side 1 terminate it 1 and its return finish of this coil that is 5 dashed, you terminate it suppose on 2. Got the point? This is how the coil sides are terminated. This is coil number 2. In case of series motor, we know I mean DC motor, we know that all coils are to be connected in series and the circuit should be closed and we will tap the voltage intelligently by putting some brushes on the commutator segments. That is what I told. So, this is coil number 1 is over. So, coil number 1 is, if I draw it like this, I will draw like this 1 and 5 dashed, 1 5 dashed. In case of DC machine, another information it is better to keep track of that these coil ends are terminated in which commutator segments. I will write side by side, 1 has been terminated to commutator segment 1 and 5 dashed has been terminated into commutator segment 2. Now, these two ends where they are terminated, the difference in the number of this commutator segment is called commutator pitch. So, Y c, which is called commutator pitch is equal to, we say it is 1 next commutator segment. Now, this thing, then what I will do? I will start the next coil. I am drawing with a other color, so that you can easily distinguish. So, it should be connected in series. So, I have started my journey from this, come here, then I will connect it like this, and this 2 will be returning through 6 dashed. Therefore, it will go like this, it will go like this and come back to 6 dashed here, and then this 6 dashed I will terminate it on commutators, next commutator Y c is 1, 3 minus 2 1, and then I will further proceed. Do not consider it to be R y b, no, just to distinguish, so that I can trace this. This is the second coil, that is all. And then you connect the third coil in series, it goes like this. It will come back through 7 dashed here, and it will be terminated on 4. Then 4 starts, got the point? And this way it will continue. I will not draw further. 4, then 8 dashed it will go. This last one let me draw. 8 dashed it will return, and it will be terminated on this. In this way, I will go on completing the winding diagram, and you will find the winding diagram will be completed. And so, with this in mind, so I have to calculate what is the coil span. Coil span is this length, mind you. Take any coil, say coil number 1, this is the coil span. This is coil span. And what is this? This is Y c, coil Y c, commutator pitch, which is plus 1. They say plus minus 1. You could also terminate it to this terminal, winding will be happily progressing, no point, but let us restrict to discussion on 1. So, it is called a simplex lap, progressive lap winding. Winding progresses from left to right. If Y c is assumed to be minus 1, it will progress in the opposite direction. Okay. Achha, these things in this way, this elaborate diagram, instead of drawing, I also told you. So, let us go to next idea, that I have taken S equal to 16, number of poles equal to 4, coil span should be 1 pole pitch, because of to maximize the induced voltage in a coil. If one coil side is under north pole, other coil side you try to see it is under south pole, center of the south pole, like that. Coil span is equal to 4, and winding commutator pitch is 1, that is what plus 1 I have taken. Now, this thing I will draw in this way. I now know what it is. Suppose I will make a winding table now, winding table, and say that the first coil I will draw it like this 1 and 5 dashed, is not? And then as I told you, it is better you keep track of where these two ends are terminated. So, here you write commutator segments on which ends of a coil are terminated. So, where this one is terminated at 1 and where 5 dashed is terminated in commutator segment 2. Go back here. 1 is terminated on 1, then it comes out from 5, but you are bringing it back to 2, to commutator segment 2. Then the next coil you have to connect it in series. So, what you will be doing? The next coil, second coil is which coil? 2. And 6 dashed, red one, 2 and 6 dashed. So, 2, so commutator segment 2, so from 2 this is 6 dashed, and 2 is this coil ends are terminated between which 2 points? 2 and what? 3. Look here, 2. It goes, it comes back 6 dashed, it is terminated on 3, and this way it will produce, it will go on. This will be 3. So, coil span is 4, you write a 4 here, and here it is plus 1 only commutator segment. So, 3 plus 4, 7 dashed. So, this will be 3 and 4, these two ends where they are terminated. In this way I will proceed, and then all the coils I have connected them in series, is not? I will go like this. So, this is how we discussed about lap winding. Now, in a much visually attractive way, okay, this is how things will go on doing like this, and then the last job that will remain is on which commutator segment brushes are to be placed. I told you, show the polarity of the voltages, where plus sign will converge, there you put a positive bar, and where the negative voltages will converge, put the negative brush. And in case of lap winding, if the number of poles are 4, you can put 2 positive brushes and 2 negative brushes, and that will divide the armature into as many parallel paths as the number of poles of the machine. That I am not going to discuss. But why I have once again discussed this lap winding is simply because to understand what we are going to do in wave winding. One thing you must understand, after you complete this winding, put the brushes, separation between the brushes in terms of commutator segments, it should be how many commutator segments? Separation, we have seen this separation between positive and negative brush in terms of commutator segments number, commutator segments should be equal to how many? C by P. C is equal to S, that is okay. but so if positive slot is somewhere here, because it depends upon which are plus, which are minus, we have discussed this earlier. So, if it is 5, see the earlier notes on the lap winding. Then in terms of commutator segments, this 16, this is also, hello, once again top this diagram. This in terms of this brushes, in terms of this you count, if it is plus here, then after C by P, P is the number of poles of the machine, that is there 360 degrees. So, 180 degree apart it should come. So, in terms of commutator segments, if it is positive brush is here in space, negative brush will be C by P after that. That is all. And we have seen that in case of lap winding, number of parallel paths equal to number of poles of the machine. Now, I will discuss about the wave winding. Okay, lap we have understood earlier, I have just reviewed that. Now, in the wave winding, what we will be doing? So, please complete this. Complete, it is your job, complete this table. See, in fact, after you have drawn several things, it becomes a simple number game. That is why the coil sides are numbered in that way. Okay. 1 5 dash, 2 6 dash, 3 7 dash. I will not now refer that sign. I will simply say, okay, then it will be 4 and 4 plus 4 8 dashed, that is all. Next one will be 5 9 dashed, and so on. There will be 16 coils and all of them are in series. And assume coil size 1, 2, 3, 4 under north pole, put plus plus here and so on. We have discussed that. Now, let us come to wave winding. Here 17 are there. Achha. Wave winding, what it is? One, two, three, 4. Achha, previous 16, na? 16 are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 slots are there. Now, I will just mention before that in word what this winding, lap winding and wave winding, in which particular way they are different really. What happens is this, all the coils are identical, it has got a coil span. The difference in different types of windings, that is lap, wave, etc., is that how the ends of the coils are terminated on the commutator segment. In case of lap winding, you terminate the two ends of a coil in the consecutive commutator segments. Okay? For example, what I am trying to tell is this. Suppose the same problem, S is equal to 16, P is equal to 4. Okay? Coil span is equal to say 16 by 4 is equal to 4. And winding pitch I have not yet decided, a commutator pitch means what? You start with slot number 1. This is commutator segment 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and after that once again 1 will come. And we have seen that this numbering I will do like this, 1 1 dashed, 2 coil sides will be there in each slot, then 2 2 dashed, 3 3 dashed, 4 4 dashed, 5, 5 dashed, 6 dashed and so on, 7, 7 dashed, 8, 8 dashed. You may feel slightly bored, but better do it like this 9, 9 dashed, 10, 10 dashed. Each slot, this is slot number 10, 2 coil sides, 11, 11 dashed, 12, 12 dashed, 13, 13 dashed, and they are occupying same position, dotted line because it is below the upper coil side, 14, 14 dashed, 15, 15 dashed, 16, 16 dashed. Now, the first coil, okay. You have started with this one commutator segment 1 and its coil span is 4. I must see to maximize the voltage. So, it should be 5 dashed. So, you go to 5 dashed, its return must be 5 dashed, it comes there and then it comes here. So, these are the two terminals of the coil, which this terminal I have terminated on commutator segment 1. In case of lap winding, I was terminating it in commutator segment 2. Now, what I am telling, the ends of a particular coil, I will terminate in a different way in case of wave winding. What they say, you terminate this end at 2 pole pitch apart in terms of commutator segment number. Got the point? So, so I will do that. That is, this one here, I want this once again, another is there 16, same thing, na? 17 does not matter anyway, let it be there. So, suppose what I am telling is, suppose I say that you just be with me and try to understand what I am telling. That is, suppose I say that this is, I can arbitrarily number them, it does not matter, 1, 1 dashed, 2, 2 dashed, 3, 3 dashed, 4, 4 dashed, sorry, 5, 5 dashed, 6, 6 dashed, 7, 7 dashed, 8, 8 dashed, 9, 9 dashed, 10, 10 dashed, 11, 11 dashed, 12, 12 dashed. This is slot number 12, this is 13, 13 dashed, 14, 14 dashed, this is 15, 15 dashed, is not? Then this should be numbered as 15, 15 dashed, then have I missed 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, all are okay now, 15, 15 dashed, and then this should be 16, 16 dashed, is not? But there were total no, that is 17 I do not want to have. What I mean to say 15, 15 dashed and then suppose there are 16 number of slots, what I am telling, I will not number them. Which one? It will be erasable. Four, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15. Okay, I will tell that this is suppose 16 slots are there, then I will say this is 16, this is 16 dashed, and this is not there. Suppose there are 16 slots. Got the point? This you forget. There are 16 slots 1, 2, 3, 4, 5, 6, 15, 16, once again 1 1 dashed. Acha, here what I will do is this. Suppose this is slot number 1 and I will start my winding like this 1. Then its return is 5 dashed, pole is 4. So, slot per pole is 4. So, its return will be from 5 dashed, no doubt. Now, this one what I am telling, I will terminate it YC, I will terminate it after 2 pole pitch apart. So, what is 1 pole pitch apart? C by P, same number of commutator segment is equal to C. So, C by P 1 pole pitch, 2 pole pitch apart I will. So, what is this number? This will be 2 into 16 by 4, that is equal to 8. So, this commutator segment number, this 5 dashed, I will terminate it after 2 pole pitch apart, means in slot in commutator segment number 1 plus 8 9. So, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, this will be once again 1. This is not there, this slot is not there, 16 slots. So, this I will terminate it on this segment 9. Will it change the induced voltage magnitude? No, induced voltage takes place only in the coil sides. These are outside the magnetic field, north south here. These are overhang of the coil. So, it will be terminated here. That is the commutator pitch, this is YC, this is YC, is 2 pole pitch apart. This is the first coil. Then the next coil I will connect in series. Where should I start the next coil? From this commutator segment dictates me the slot number I will go. So, 9 I will connect it to next coil, I will connect it here, and its span is 9 plus 4 13 dashed, is not. So, 9 plus 4 is 13 dashed, it will come over here and then it comes over here, but I am not going to terminate it on 10. This time commutator pitch is 8. So, 9 plus 8 is how much? 17, means 1. So, it will be terminated on 1. 1 means here. So, after tracing 2 coils, you have finished. I mean, what to do? Winding is closed. Therefore, you see, in case of lap winding, number of coils between 2 consecutive commutator segments is equal to always 1. But in case of wave winding, I am trying to do using a full pitched coil, and I find that if I plan to choose my commutator segment YC to be equal to 2 pole pitch 2C by P, then after tracing 2 coils, you come back to the same starting point here. This was one. Na? Here we started from here, trace these 2 coils and come back here, and 2 coils are in series and closed, but so many slots are still remaining to be made use of, we cannot do anything. Therefore, we will see that we have to make a little bit of compromise to implement the wave winding when we shall try to use full pitched coil span is this whole coil span, that is 4 we chose coil span. At least we conclude that this way if somebody tell me to complete the winding, it is not a better solution, only 2 coils everything is over. So, we will continue with this in the next class.